Naming haloalkanes can be a little tricky at first, but in this video, I'll show you how to decode organic names step by step using a few simple rules. By the end, you'll see that naming organic compounds is more like solving a puzzle than doing hard math. Let's turn confusing names into something you can actually understand. Welcome back to the channel where our goal at Tadashi Science is to make science simple. Make sure to subscribe so we can continue to help you on your science journey. Before we look at naming haloalkanes, we need to first know what a haloalkane is. A haloalkane is simply an organic molecule that contains a halogen bonded to an alkane molecule. It is important to remember that the halogens are the group 17 elements fluorine, chlorine, bromine, and iodine. And an alkane is just an organic molecule with only single bonds. Organic chemistry is carbon-based chemistry and deals with chemical structures built around a carbon backbone. The identifying feature of a haloalkane is that you have a halogen bonded to the alkane chain. So here you see a few examples of haloalkanes. The one thing you should notice about all these molecules is that they are all alkanes with different halogens bonded to them. Now that you can recognize and identify haloalkanes, let's look at how to name them. When naming any organic compound, the first thing you need to do is identify the longest carbon chain. So when we name haloalkanes, we're going to count the longest carbon chain we can find. The longest carbon chain will not always be straight, and it will not always be counted from left to right. So it is important to pay attention to any bends in the molecule, as we are looking for the longest continuous carbon chain. As we count each carbon, we will number the carbons. The number we assign to each carbon will be important, and you will see that as we look at different examples a little bit later in this video. Once we count and label the longest carbon chain, we will then use a specific stem that is related to the number of carbons in the chain. Here is a list of the stems we will use if we had an organic molecule with a carbon chain that contained anywhere from 1 to 10 carbons. For 1, we would use meth, 2, we would use eth, all the way to 10, we would use the stem dec. These are the same stems that we use when naming alkanes and all other organic structures, so it is a good idea to memorize these. This video will only cover naming haloalkanes, which means there will only be a single bond in the molecules we look at. This also means we can use the ane ending like we did when naming alkanes. If you have not watched our naming alkanes video, go check it out and then come back and finish this video. The other important thing to know when naming haloalkanes is what prefix should be added before the stem. The prefix that we will use will depend on the halogen that is present. The prefixes for each halogen are listed here. So the stem correlates to the number of carbons in the carbon chain, while the prefix corresponds to the halogen that is present in the molecule. So now that you know how to identify haloalkanes and the correct stem and prefix to use when naming them, let's look at some examples. So in our first example, we'll look at a simple structure with one halogen bonded to the carbon chain. I'm going to start by identifying the number of carbons in the chain, and this one is pretty easy with only one. So I'm going to use the stem meth. I am then going to add the suffix ane because I'm dealing with an alkane, as these are all single bonds. I then have to account for the halogen bonded to the carbon chain by adding a prefix. The halogen that has been added to the carbon chain is Br, or bromine, and I'm going to use the prefix for bromine, bromo. So once I add bromo to the front, I'm going to have bromomethane. In our next example, we will look at a little more complex structure. However, the process will stay the same. I'm going to first number my carbon chain to identify the stem I need to use. When we number our carbons in a haloalkane, we want to make sure we start numbering from the side of the molecule where the halogens are located. We want to ensure that the lowest number possible is on the carbons that the halogens are bonded to. So in this structure, I'm going to start on the right side and work right to left. I see that I have 4 carbons, so the stem that we're going to use is bute. Again, there's all single bonds between the carbons, so I'm going to add the suffix ane because I'm dealing with an alkane. I then will account for the 2 chlorines bonded to carbon number 1 and 2. I'll add the prefix chloro, but I also need to add di before that in order to account for there being 2 chlorines in the structure. These chlorines could be bonded to any of the carbons 1, 2, 3, or 4, so we need to account for which carbons they're actually bonded to. So in front of dichloro, I need to add a 1 and a 2 so I can tell the reader that I'm adding the chlorines to those carbons. So this structure would be called 1,2-dichlorobutane. In our last example, we'll look at this structure here. Again, we're going to start by numbering the carbon chain, and I'm going to number this molecule from right to left because my bromine is closer to the right side. I see that I have 4 carbons, so I'm going to use the stem bute. There is all single bonds between the carbons, so this is an alkane, so I'm going to add the ending ane after bute. I then need to account for the bromine that is bonded to the second carbon, and I'll do that by adding the prefix bromo and the number 2 to account for the halogen being bromine and it being bonded to the second carbon. So the name of this molecule would be 2-bromobutane. Now you know how to name haloalkanes. If you found this video helpful, here's another video to check out. Make sure to like this video and subscribe to our channel as we produce more content to make science simple.